I present my schema solution for a database that can be used in the development of a QA system diagnostic application. This project was done as part of the final process to obtain the CSSD certification in SQL from Harvard. This project is inspired by an Excel spreadsheet created by my father, engineer Javier Sanchez Aragon, as a simplified guide to diagnose potential problems in cooling systems. With the aim of taking this Excel to a mobile app, this database allows to record and analyze key data to diagnose the status of a refrigeration system. For this project, the initial focus is on analyzing specific temperature and pressure readings, determining the likelihood of certain causes of a problem in a cooling system. Each cooling system within the scope of this project is composed of a compressor, an evaporator, a special valve, and a condensing unit. The user can record readings for each of these components. These readings are associated with the analysis log, where from the data entered, the necessary calculations are automatically generated to determine a diagnosis on the status of certain system criteria. The generated diagnosis is compared with the problems defined in the possible problems table, where each problem is represented by different conditions. These conditions are compared with the diagnosis, and depending on the number of matches, a probability is assigned to each problem, within a scale from 0 to 5. For example, the database is preloaded with test data. If we run this query in SQL, we can answer the question: what are the 3 most likely problems affecting the cooling system of the company DevPoint based on the most recent reading? As an automatic result of analyzing the readings, DevPoint's refrigeration system could have the following problems with a probability of 2 on a scale from 0 to 5. The user might conclude that the problem is electrical in origin, as temperature and pressure-related problems have low probabilities. Even so, this system is not perfect because it has certain limitations, such as the lack of support for systems with multiple evaporators and lack of real-time monitoring of equipment performance. However, these features could be implemented in future versions of the system. But for the moment, thank you for your interest in this project. For more details on the database design, schema, and optimization, you can find the code in my GitHub repository. I also include a link to a Notion page with more detailed information about each part of the schema. Thank you.